means what we have discussed this question. So what we are going to do, we are going to discuss about the connected components now. I hope you have already heard about this question. So how we are going to do, the question will be same like this, but let's say if this question is the same, if someone is asking, please tell me what is the number of groups that we have created in this question. Let's say if he has given us some input, let's say something like this, and he's saying what is the number of groups that has been created. In this case, it will be the first group will be this, second group will be this, and third will be this. Okay. Yes, I hope there are three groups only. Ankit, Rahul. Okay. So this will be the connected components. Okay, I'm going to repeat the question again. Uh, so let me erase this first. So let's say I'm going to draw it in the integer form. Let's say 0 is here, 1 is here, 2 is here. Okay, and let's say a node 3 is here, 5, let's say this 5, 6, and 7. As we have already discussed that although these graphs are not connected, but we can say that this is a single graph, and these are the subgraphs of that graph. Okay, so this will be the first one, the first subgraph, the second subgraph, and the third subgraph. Okay, so what we are doing here, what we are going to do, we are just going to count what are the number of connected components. Let's say in this case it will be 3 because these are the connected, and this is connected. These three nodes are connected, and these two nodes are connected. So we are going to count how we can know that what are the number of connected components are there. Let's say in this case, there will be same with this question. In this case, we are talking about the number of groups. It means, let's say A and A, one is in front of 0, 0 is in front of 2. It means this is the one. This is one group of friends, and this is the another group of friends, and this is the third group of friends. Okay. How we are going to do this question? First, tell me whether question is clear. The number of connected components. Is it clear? Okay. So now how we are going to do? Let's say if someone asks how we are going to do whether 0, 1, and let's say 7 or let's say 10 is here. So how I can do that? For traversing in the graph, we have already created and visited map. Okay. So how I'm going to do? First, I know what are the nodes that are being present. Let's say 1, 0, 2, 4, 3, 5, 7, 6. I know these are the nodes that is being present into my graph. So how I'm going to do that? I'm going to start. Let's say for traversing a graph, I need a starting point. I need something from where I can start. Let's say in that case, what I'm going to do, I'm going to start my traversal from each and every node of the group, each and every node of the graph. Let's say I'm going to start my traversal from 0, 1, 2, 10, 3, 4, 5, 7, and 6. Okay. So how I'm going to do that? Let's say I'm going to create a DFS or VFS function. In that case, what I'm going to do, let's say I'm going to uh, start my DFS traversal from 0. So I'll be passing my let's say visited map with that function. 0 will start its traversal and 0 will print 1, 2, 10 and 0, 1, 2, 10. That's it. And it will update the visited map for that 0, 1, 2 and 10. It will mark it true that we have already visited. Let's say I'm calling my functions for now for 1. Before calling my function for 1, I'm going to check whether this 1 is being visited or not. If it is being visited, I'm not going to call this function again. For 2, again, I'm going to check whether this is being the 2 is being visited or not. Yes, 2 is being visited because in this we have already printed, so I'm not going to call my function again. Again it comes for 3. If 3 is being visited, no, 3 is not being visited, so I'm going to call my function and I'm going to call dfs function and I'm saying start traversal from 3. So in that case what we are going to do, it is going to print 3, 4 and 5 and it is going to mark 3, 4 and 5 as true. So after that 4 come in that case, if let's say we are running a loop, in that case we are going to check whether for 3 we have completed our traversal. For 4, 4 is already being visited, so I'm not going to call my function for 4. 5 is already being visited. 6, yes, 6 is not being visited, I'm going to call my function for 6. 6, when I call my function for 6, I'm going to say that 6 and 7 will be printed. So again, if I call my function for 7, this function will not be called because we have already visited this node. After 7, 8, 9 is not there. Let's say 10 is here. I'm going to call my function for 10, but 10 is already being visited. Okay. So we are going to just count what is the number of, can you, okay, I'll repeat it again. Just I'm going to count what is the number of, times that we have called our function, a DFS function for the traversal. Let's say we have created a DFS function for traversal and I'm creating a visited map. Okay. And I'm saying pass this visited map with that DFS traversal. Although in the case of DFS traversal, we have already passed or visited, means we always passed or visited map. So in this case, what we are going to do, let's say I'm going to run a loop and I'm going to call the DFS function for each and every node present in the graph for 0, 1, 2, 3, 4, 5, 6, 7, and 10. Okay. First for 0, it will be called. So with 0, this visited node, this visited map will be passed. So in the initial phase, for all the nodes visited will be false. So what it is going to do, it is going to print 0, 1, 2, and 10, because after 10 it is not going to print anything because there is nothing in this subgraph present. What DFS print? DFS print all the connected nodes that is there in that subgraph. Okay. So for 0 we have printed this, and 0, 1, 2, and 10 is marked true in this visited node. Again, although we are running a parent loop, so it is going to check whether for 1 we are going to call this function or not. So it will check whether 1 is being visited or not. So which in the visited function, 1 will be marked true. 1 we have already marked 1 true. So it is going to say that we have already visited 1. So there is no need of visiting it again. So it will not call this function for node 1. And again, in the same case of in the case of 2, 2 has already been visited, so we are not going to call our function for 2. Again, in the case of 3, 3 is not being visited yet. So what I'm going to say, I'm going to visit this, I'm going to call my DFS function, and I'm going to say that call a DFS function and start my traversal from this node. So that function will start the traversal and mark 3 as 2, mark 4 as 2, mark 5 as 2, and will print all these nodes. Okay. And now it will return, this function will return it has already completed task, so it will return. So after 3 we are going to check whether 4 is being visited or not. So 4 is already being visited, so I'm not going to call my function again. So 5 for 5 5 is already being visited, so I'm not going to call this function again. For the 6 as well, yes, 6 is not being visited, so I'm going to call this function for 6 again. In the case of 7, 7 will be visited because if I call my DFS function for to start my traversal from 6, the 6 and 7 will be covered in that function call. Okay. So the 7 will be marked true, and after that 8 and 9 are not there. Let's say 10, I'm going to start my traversal for 10. So 10 is already visited, so I'm not going to call my function. So I'm just going to create a count variable. If before calling, if I'm checking if this node is being visited or not. If it is being visited, I'm not going to uh, increase my count. This node is not being visited, and if I'm calling this DFS function for this node, it means I'm going to increment my count. Okay. Let's say, okay, is that question is means the concept is clear with everyone or not? If it is clear, I'm going to code it. Then you'll be more clear about it. Okay, Shrey is saying it is clear. Shrey Doshi, is it clear or not now? Okay, let's start with the coding part. Let's say class. Here I'm going to what I'm going to do. I'm going to create an integer type of graph. Let's say unordered map. Okay, let me quickly do all this. Let's my spelling right now. So to be the end, I will be the vector. Let's say name it map. Create some public function that is void let's say I will create a pool in this case. Yeah, if okay, let's first do map of A or push back B into it. If BI is true, what you need to do map of B dot push back A into it. Okay, we have created our add as function. So what I'm going to do now, I'm going to create, let's say, connected component function. Let's say name is connected. So I will not take anything. I'm going to check what I'm going to do. I'm going to create a count variable and I'm going to create an unordered map of vegetate int comma bool starting all the values will be false. Okay, let's say its name is vegetate. Okay. And now what I'm saying, uh, run a for loop for all the values of map. Okay. So in the x dot first we'll get all the nodes. Let's say in the x dot first we'll get 1, 0, 2, 10, 4, 3, 5, 6, 7. Okay, it can be in any order. So we'll get in the x dot first we'll get all the nodes there, all the nodes, and will not get any duplicate values. Okay, so what I'm saying, if vegetate of x dot first, vegetate of x dot first is false. If it is false, it is going to return in true. If this condition satisfies, what you need to do, you call DFS function. You call the DFS function and pass or visited node, pass or visited map as well as the starting point is now first because it is not being visited yet. If this condition satisfies, it means we are going to increment or count, or in the any other case we are not going to increment or count. So I'm going to print number of connected and number of connected components is, let's say, that count. Okay. Yes. Is it fine now? So what I'm going to do now, I'm going to just create my DFS function. I think we have already discussed that. So void DFS. What we are doing in the case of DFS, rejected. So it will be unordered map. Int comma rejected. We have already discussed why we are going to pass it as a reference because we are going to use recursion and the value the updates will be visible in the another function call as well. Okay, let's say the another is the end start. So what I'm going to do now, I'm going to print st. Let's say I don't want to print st because this I'm going to create this DFS function according to myself. let's say I've been being printed AFS. What I'm what I'm going to do, I'm just going to visited mark the visited of STS. Okay. What we need, we just need to update our visited node. It means if visited of let's say I'm starting from at 0, 0, 1, 2, and 10 visited of it will be marked as true. So if in the next case, if I'm going to call this function for 1, so it will say that we have already visited this node. Okay. So what I'm going to do now, I'm going to uh, I'm going to call my AFS function for all the nodes that is directly connected with this node. So that will be the map of ST, and I'm going to check if it is not being visited at, let's say X is not being visited at, to call this function for call this AFS function that is let's pass my visited through it and pass the X as the starting node now. Okay. We have already discussed this, I think so, AFS function. Now let's quickly add some data. Let's see whether we are getting the correct output or not. Graph C dot add, it is 0 to 1 dot add 0 to 2. So it is add edge function is there. Add s is there. So 0 to 1, 0 to 2, and 2 to 10. Another one is 3 to 4, 4 to 5, 4 to 5. Another is 6 to 7. Okay, 6 to 7. Let's say G dot connected. I think it was connected or components connected. The function is connected. Let's see what is the output that we are getting. Okay, we are getting the output as 3. Is the question, is the code is clear with everyone? Or do anybody is having any doubt? If you are having any doubt, you can ask. I can repeat it. Okay, you can go through the code again. Uh, no, it's clear. Okay, thank you, Shrey. Okay, thank you, Smith. Shrey is saying yes. Shrey, do I need to repeat it or is it clear?